I'm Muskan from SVC, and today I'm going to be presenting on the topic the pumping lemma for context-free languages from Theory of Computation. So let's dive into it. The pumping lemma is a powerful tool in the realm of formal languages. It allows us to prove that certain languages are not context-free, which are languages that can be recognized by a push-down automation. We will explore its applications and delve into the underlying principles of its construction. So, what is a context free language? Let's see the definition. A context free language is defined by a set of rules known as a context free grammar CFG. These rules generate strings by recursively substituting non terminal symbols with other symbols or terminals. For example, the rule S becomes A, B can be used to substitute the non terminal symbol S with the symbols A and B. Examples of CFLs include the set of all balanced parentheses, the set of all strings of the form a to the power n, b to the power n, and the set of all arithmetic expressions. Context-free languages are widely used in computer science for representing programming languages, data structures, and natural language grammars. Motivation for the pumping lemma. Proving non-context freeness. The pumping lemma provides a way to prove that certain languages are not context-free. If a language satisfies the condition of the lemma, it cannot be generated by any CFG. This is useful for understanding the limitation of context-free grammars and identifying languages that require more powerful formalisms. Understanding language properties. The pumping lemma helps us understand the inherent properties of context-free languages. By analyzing the structure of strings generated by CFG, we gain insights into the limitations of this type of grammar and the types of patterns that can be generated. Defining the pumping lemma. The pumping lemma states that for any CFL, L, there exists a pumping length P such that any string W in L with W more than or equal to P can be pumped by repeating a substring within W. This means we can create new strings in language L by inserting copies of that substring into W. The repeated substring must be non-empty and the pumping operation must be performed within a specific range. Constructing a pumping set. The pumping lemma can be used to prove that a given language is not context-free. This is done by constructing a pumping set, a set of strings that are all in the language but cannot be pumped according to the lemma's condition. If you can find such a set for a language, then the language cannot be context-free. The key here is to find a set of strings that cannot be pumped while still being within the bounds of the language's definition. Let's see the application of pumping lemma. To apply the pumping lemma, first choose a pumping length P, then select a string W in L with W more than or equal to P. Next, decompose W into three substrings. W is equals to U, V, W, X, Y, where V, W, X is less than or equal to P and Vx is more than or equal to 1. Now pump the string by repeatedly inserting copies of Vx into W, creating a string UVW to the power IXY for all I more than or equal to 0. If any of these pumped strings are not in L, then L is not context-free. Let's see examples of using the pumping lemma. Example 1, the language A to the power n, B to the power n, C to the power n, and n is more than or equal to 0. This language consists of string with an equal number of A, B, and C characters. Using the pumping lemma, we can prove that this language is not context-free by showing that any string in this language can be pumped, but the pumped string will no longer have an equal number of each character. Example 2, the language A to the power n, B to the power m, and C to the power n. Here n and m are more than or equal to 0. This language consists of strings with an equal number of A and C characters. We can show that this language is not context-free using the pumping lemma by demonstrating that any string in the language can be pumped to produce a string that does not have any equal number of A and C characters. Conclusion and key takeaways. Power of Pumping Lemma. The Pumping Lemma provides a powerful tool for providing that certain languages are not context-free. It can be used to demonstrate the limitations of CFGs and identify languages that require more complex formalisms. Practical applications. Understanding the Pumping Lemma has practical applications in computer science, including the design and analysis of programming languages, compiler construction, and formal verification. Further exploration. The pumping lemma is a fundamental concept in formal language theory, and there is much more to learn about its applications and extensions. Exploring topics like more complex classes of languages and limitations of pumping lemma can provide a deeper understanding of formal languages and their capabilities. Thank you.